Hi, I'm Swarupa Sale, course instructor for Geotechnical Engineering 1. Now we'll go through Flownet. The solution of Laplace equation requires knowledge of the boundary conditions. Geotechnical problems have complex boundary conditions for which it is difficult to obtain a closed form solution. Approximate methods like graphical methods and numerical methods are often used. Flownet technique is a graphical method which satisfies Laplace equation. Flownet is a graphical representation of a flow field, that is solution of Laplace equation, and it comprises of both flow lines and equipotential lines. Here in this figure we can see the equipotential lines represented by phi and flow lines which are represented by psi. We already have studied about equipotential line and flow line under fluid mechanics. A flownet is a two-dimensional diagram of equipotentials, that is lines of equal head, and flow lines psi. Equipotentials represent points of equal potential head, and flow lines or streamlines correspond to directions of groundwater flow. Equipotentials are usually denoted by H1, H2 or phi1, phi2, and flow lines are represented by psi1, psi2, etc. Delta Q is constant, which is equal to K into hydraulic gradient, that is delta H divided by L into A. Delta Q1 is equal to delta Q2, where delta Q1 is equal to flow rate between psi1 and psi2. A is equal to area of flow tube, K is hydraulic conductivity, L1 is the distance between equipotentials as seen from this diagram, that is phi1 and phi2. Similarly, L2 is distance between phi2 and phi3, and A1 is the cross-sectional area of flow tube, and A2 is the another cross-sectional area of flow tube which is of length L2 and A1 of length L1. The rate of flow can be inferred from flow nets if the hydraulic conductivity is known. Total volumetric rate of flow Q can be calculated using formula NFK delta H, which is equal to NF divided by NE into K into H, where NF is number of flow channels, NE or ND is number of equipotential drops, and H is equal to total head drop. Here H is equal to NE into delta H. Characteristics of flow net. Discharge Q1, Q2, Q3 through each flow path are equal, and total discharge Q is equal to Q1 plus Q2 plus Q3. Potential drops H1, H2, H3 between any two adjacent equipotential lines are equal, and total drop H is equal to H1 plus H2 plus H3. Flow lines and equipotential lines are orthogonal, that is they intersect at right angles. Flow lines do not intersect. Similarly, potential lines do not intersect except at boundaries. Flow lines and equipotential lines form square figure, that is their corners are at right angles and median distances are equal. Convergence of flow lines means concentration of flow and increasing hydraulic gradient, and divergence of flow lines indicate decreasing hydraulic gradient. So here we can see a concrete dam, and the head between the water level in the reservoir and the water level at the downstream section is HL, and we can see the flow lines drawn and the equipotential lines. We can see that the flow lines and equipotential lines intersect at right angles, that is 90 degree. The points along the equipotential line will have the equal head which causes the flow. If we place the piezometer at different points along an equipotential line, the water level will be same. This is the line which represents the flow net and also called as a drop line. The equipotential line will not meet another equipotential line. Head drop between nearby equipotential lines is constant. The construction of flow net starts with marking of boundary conditions. The flow velocity of water normal to the boundary line is 0. The boundary condition for flow lines is formed from the impermeable boundary. The submerged surfaces form boundary conditions for the equipotential lines. During the construction of the flownet, some conditions to be followed. The flow line and equipotential line will intersect each other at right angle. The flow tubes formed by flow line and equipotential line should be approximately square in shape. It is used for the estimation of the seepage loss in the soil or through the base of the dam or reservoir, uplift pressure below the dam, seepage pressure, pore water pressure and exit gradient. Thank you.